Okay, these are the chapter 3.7 notes, inverse functions. This is page 1. So we talked about relations earlier. We can have a relationship between an input and an output, or an x and a y, without it being a function. Remember, there are additional rules that apply that make it a function. So to create an inverse relation, we're just going to swap the x and the y. Interchange the first and second coordinates. Swap the x and the y. That's all we're doing. Okay. If we are talking about an equation, then when we swap those, we get the equation for the inverse relation. So if we start with an equation, we end with an equation. So let's take a look at example 1. We've got a relation given by G. It's the set of 3 ordered pairs. We want to find the inverse relation. So it's an inverse, so G to the negative 1, G inverse. And it's still going to contain 3 ordered pairs. And all we're going to do here is swap the x and the y. There's the inverse relation. If you know a point on a function, you know a point on its inverse. Okay, and sometimes, because this is the most basic way to look at inverse functions, sometimes we forget these. So let's take a look at example 2 here. Here we have a relation. It's written as an equation, y equals x squared minus 5x. Just a reminder, we can factor this, which tells us we have zeros at x equals 0, x equals 5. One, two, three, four, 5, can't tell. Okay, and then we know this is a parabola, it's a quadratic. If we want to find the vertex, we know it's going to be halfway between the zeros. So the vertex is at halfway between 0 and 5 is 5 halves. And then we just plug in that 5 halves. We're going to square that. We're going to subtract. 5 halves squared is 25 fourths. 5 halves times 5 is 25 over 2, which makes it 50 over 4, which gives us negative 25 over 4. So about 6 1/4. So there's my 2 1/2. 6 1/4. Let me be consistent with my colors. It's still not red. And there's our parabola. Okay. We want the equation for the inverse. And we're going to do what we did above. Just going to swap the x and the y. So everywhere I have a y, I'm writing it as x. Everywhere I have an x, I'm writing it as a y. Typically, we don't graph stuff that looks like this, the sideways parabolas. But I can take the points that I have on this curve. I've got 0, 0. I've got 5, 0. And I've got 2.5, negative 6.25, going from fraction to decimal. which means that if I want to graph that inverse relation, I can swap, I still get 0, 0. I get this point, 0, 5. And then I get this point, negative 6.25, 2.5. And then I draw the curve that goes through those 3 points. Okay. So we can take a look at the points that we used here. And the fact that to put them on the inverse, we swapped them. If you'd like a cleaner copy of that graph, you can scroll down to this second page, and you have that right there. Let's take a look at this mathematically first, and then we're going to go and do a whole bunch numerically. Example 3. A function is 1 to 1, and that's what we're focusing on here. Now, we are talking about functions that are 1 to 1. Basically means both the original function and its inverse are going to be functions. So a function is 1 to 1 if different inputs have different outputs. So let's see what that says. That says if different inputs, so some x that I choose, I'm going to call it x sub 1, does not equal x sub 2, does not equal that other x that I find. If my inputs are different, then my outputs are going to be different. It's one way to tell if a function is 1 to 1. Or let's go backwards. A function f is 1 to 1 if, when the outputs are the same. So if my outputs are the same, so f of x sub 1 equals f of x sub 2. The only way we can get that is if our inputs were the same. Okay. The last part, inverse of a 1 to 1 function is also a function. We call it f inverse. It's written this way. F to the negative 1, that just means we're talking about an inverse function of f. Notice that negative 1 is not an exponent. It's not like we're using it on a number or a variable. This is just letting us know that this function is an inverse. Okay. What that means is if I can plug in x to a function and get out y, I can plug y into its inverse and get out x.